Okay, I'm going to show you some projects I've been working on using basically these two processors that you see. The one on the right is the Arduino Nano. I like it because of the small size, makes it easy for projects. And the one on the left is the Node MCU, which essentially is an Arduino with a ESP8266 Wi-Fi module built right into the chip. All of the projects I've been working on recently connect up to either an iPad or a smartphone, and we do it with either Wi-Fi, which is, as I said, on the chip to the right here is the Node MCU, and it has the Wi-Fi chip built right into it. The one in the middle is the same thing as that metal covered part right there. It's an ESP8266, which is pretty standard Wi-Fi module that I can connect up to the Arduino Nano. And then the one on the left is a Bluetooth module. So you can connect up to a phone or iPad with Bluetooth. There's different versions of this. The older ones are called the HC4, 5, and 6. They are just regular Bluetooth. The newer ones are HM8, 10, and 11, and those are the BLE, or Bluetooth Low Energy. And if you're going to use an iPad or an iPhone, you have to use one of those because they only accept the Bluetooth Low Energy BLE. I know this is kind of fluttery, but I wanted to show you for all the projects to program both the Arduino Nano and the Node MCU. I use the Arduino IDE, which is the development environment. And I'm going to go in close and you can see some of the code, and it's relatively easy to do. There's plenty of online lessons, and it's an open source system, so you can find bits and pieces of code that you need in different places. The cool thing about it is if you look at the top, it says SPI.h, Adafruit, GFX.h, and Max72XX panel.h. The way Arduino works is there's the main software to run the Arduino chips, and then you can put in this add-on software to do additional things. The only kicker is a limit as to how much memory that the Arduino modules have, roughly around 20 to 32K, so you get kind of limited as to how many things you can do with one chip. Okay, the first project I'm going to show you, I'm using an older Bluetooth module, a HC05, the Arduino Nano, a couple of LEDs, a green and red one, and a battery pack. And these are actually 3.7 volt lithium batteries, and they're running in series, so I'm sending 7.4 volts to the volts in of the Arduino. It has some regulators so I can get 3 and 5 volts out, and that's what's feeding the Bluetooth module. And I'm going to turn that on. You'll see the light come on for the Arduino, the blinking light for the Bluetooth module. And for this one, I am going to use an app that's on an Android phone, Arduino Voice. And you open it up, push connect, you connect up to the HC05, it says connected. Now you'll see the little light is blinking differently now because it's communicating with the phone. And all you got to do is you press the microphone button, red, and you see the little red light comes on. And I'm going to push it again, and it'll be easier to leave the video down here. Green.
Green.
And it turns the green light on. Off.
Off.
And it turns the lights off. So you can coordinate the text that you're going to send via voice through the Bluetooth module to the Arduino and the Arduino program that you wrote. And the program for this is pretty simple, but it shows that you can do a voice command control using an Arduino and Bluetooth. Okay, this is the second project I'm going to show you. It again is using an older Bluetooth module. It's the HC06. I've got an Arduino Nano. I've got a green LED, some resistors to set up the proper voltage for the Bluetooth, and this time I've got a little LCD screen. And what I'm going to use is a different app called Blink, B-L-Y-N-K, and it's a cool app. You can find it online, relatively easy to, there's really no code to it, if you will. You have to write the code for the Arduino. But what Blink does is it allows you to choose what sort of computer chip you're using, the Node MCU or an Arduino Nano or Arduino Uno, whatever, and you can add what's called widgets, buttons, sliders, all different types of things, and create individual separate apps to communicate with the Arduino family of microprocessors. In this case, we're going to use this one called a Bluetooth terminal, and I've got a terminal panel here, and I'm going to start up the module, and you have to push this little Bluetooth widget, choose the proper Bluetooth module. She's going through the sequence of connecting. And it's taking its time. I'm going to go back, try one more time. Just having a hard time finding this. Come on, connect up. There we go. Okay. So we're connected. We go back. We start up the software, and you can see the light on the Bluetooth module has stopped blinking. Now we're going to type in anything that you want, push enter, and we come over here and you look at the little LCD screen, and it's new. So I'm going to type in another command, and you can see how it shows up on the LCD screen. So via Bluetooth I'm communicating with text, but I can also send a command. So I programmed the Arduino that if it receives the number 1, it's going to turn on that green light, which you can see right there. If I send it a 0, oops, turns it off. 1 on, and you can see the 1 is showing up on the LCD screen, turning it on. 0, turning it off, and that shows up on the LCD screen. So the LCD screen is mimicking anything that I communicate through the Bluetooth. So now you've seen voice commands and text commands using Blink. Okay, this is the next project, which is using a Node MCU Wi-Fi module and 2 small hobby servos. Unfortunately, there's a lot of wires to the servos, and that's what makes it kind of messy. I also have a couple buttons to manually move the servos, and 2 LED lights, which basically tell me when I'm at the end of the cycle for the servo. And I'm once again using the Blink software, and I call this grabber. It's simple. It connects via Wi-Fi automatically, and then I've got 4 buttons, 2 buttons for each servo to control it. So we'll see if we can get this in the shot here. So push the button, she goes one way. Push that button, goes the other way. Push this button, turns that one that way. And when I get to the end of the cycle, you can see the light come on. Turns to green. Also green, goes to red. So we're controlling servo motors via Wi-Fi, and This Blink runs on both iPads and Android devices. This old Android phone that I have is just handy for me to do it, but that would give you control of a robot arm. You could have as many as four to six servos controlled by it. And again, I'm using my simple little lithium battery module. Okay, this is my next project. I'm once again using the Node MCU Wi-Fi module. I've got a little 5-volt DC motor, and this time I'm using a driver module for DC motors, and this module is kind of big for the little DC motor that I have. You could actually run much bigger ones. And again, just another battery pack that also has 2 of those lithium batteries in it, so I'm sending 7.4 volts to the unit and then using regulators for the 5-volt control. Again, I'm using the Blink app, this time called Motor, and I've got 3 widgets on it. One is a slider, which controls speed. I'm going to start it up here. Okay, she's connected. And I push forward. And I push reverse. She goes the other way. So for like an RC car or a robot that you needed drive motors, I'm going to slide this slider back and you can see the controls the speed. And it's a cool Wi-Fi controlled module. So we've got servos, DC motors, we got voice control, and we got text control using a terminal. Okay, this is my next project, which is kind of interesting one. It's got a lot of wires to it. It's again using the Arduino Nano, a Bluetooth BLE module, 2 stepper motor drivers. They basically use analog signals to send little signals to these motors, which are very precise. They rotate by little signals that send so many degrees of rotation. It's the type of motor that are used in CNC machines, milling machines, lathes. You can set up an XY table if you wanted to make like a 3D printer, or if you wanted to make a drawing machine. You would use this type of control system to control these servos. Stepper motors. I've also included a little LCD screen which basically tells you at how many rotations I've programmed the thing to go. So I'm going to turn that on and let it fire up. Again, I'm going to use the Blink system. This is called dual stepper, left stepper, right stepper. I just use simple sliders to send a number signal to the Arduino Nano that tells it how many times to rotate the motors. Okay, I push the Bluetooth connect. I'm going to disconnect from whatever it was connected to. We want that HM soft, which is the BLE. Okay, it's connected. We go back to the system. We turn it on. You'll see that the LCD screen goes through a little stepper mode, and then it sets up the left side and the right side. Now, if I move this, you'll see the stepper motor control going. You'll see the number that I've set into it, and you'll see the stepper motor rotating. We set up the second one. See, the stepper motor control is sending the signals. We've set it at a -7, and you can see she's rotating. I'm going to switch that one to positive. We're going to a +36, and you can see it rotating back. And you can do very precise movements with these kinds of motors. So now you've seen servo motors, DC motors, and stepper motors all controlled with these simple little Arduino compatible type devices. Okay, this is the final project, which is actually a scrolling LED module sign that will connect up to an iPad using Bluetooth module, using the little Arduino microprocessor. And as I said, I'm making this for my granddaughters. It's going to be enclosed in a sort of water resistant box, and it's going to go inside a new playhouse that their father and my son is making for them. So I'm going to power the thing with a solar powered lithium, or I should say solar recharging lithium battery. This is 20,000 milliamp hours, and it will charge with solar. You can see it doing it right now just from the light. And it's got two USB ports, a 1 amp system and a 2 amp system. And I'm going to plug in this and turn this on, and you'll see what happens. Okay, I just plugged it in. The system fires up. And the default, as soon as she fires up, is it just says, "Welcome to Nora and Alice's Playhouse." And it doesn't have any Bluetooth connection at this point. I'm using a BLE module, which is the Bluetooth Low Energy, and you can see it blinking. It's searching for a connection. And this time I'm going to use the iPad, and this, see if I can get it to focus. Doesn't want to focus on it, unfortunately, but it's called Bluetooth Serial Pro. It cost $4. There it is. You can see it a little bit better. And you can program it to coordinate with programs that you put onto your Arduino chips. Connects via Bluetooth, and again, you can put widgets on there, and it includes terminals and buttons for widgets. So this one, it will automatically sync up with the Bluetooth, and if you had a program that was correlated to that particular Bluetooth, it will automatically start that program. And this is something I had already pre-programmed. And there's control buttons. You can control the brightness, you can control the scroll speed, you can erase and pause, and then I've pre-programmed text for scrolling and also a little bitmap sequence. So we'll try this. I'm going to push the happy birthday one, and you can see that it switches right over to happy birthday. And I can change the scroll speed, speed it up. And when it comes back on, I'll show you how I can make it brighter or duller. I've got all different types of pre-programmed things. Numbers, letters, Merry Christmas. But the system also has a console side, and you push that, brings you to the console of anything that's communicated to the Bluetooth device, and you push in the text block, and you can type anything that you want. But the way this identifies text versus a command is you first have to put text into these curly brackets. So you got to do the curly bracket first. We'll write testing. Close it off with a curly bracket, hit return, and you can see what happens. I'm going to go back to the functions, and the software that I'm using to help scroll this makes it very difficult to put any kind of graphics. So I came up with kind of a manual way in the program that I could put a little bit of graphics. So I've got this one button called bitmaps, and you'll see what happens when I push it. So it's got a happy face and sailboats and arrows, and it goes through a sequence. I'm going to turn off this light, make it easier to see. And as soon as the sequence is done, It goes right back to whatever was scrolling last. So that's it. Kind of a neat utilizing the text communications with Bluetooth to the Arduino to have some sort of different output. You show up on a little LCD screen. Now you've seen it show up on these LED matrices. That's something I had not mentioned, but these matrices are little 64 LED matrices that you can get as individuals. In this case, I bought two 4-module sections that I then soldered together. Using the Arduino Nano, they recommend no more than 8 of the blocks strung together, and that's what we've got here. But they're pretty cool. You can get them in different colors. You can get multicolor ones. Gets a little bit more complicated with the programming. And there's different libraries. You have to have text libraries and graphic libraries to feed to this. Essentially, whatever you want to send has to be converted into hexadecimals, which there's software that will allow you to do that too. So that's it. That's my last module, and hopefully you get some ideas here.